Hi, I'm Ayse. So I'll talk about a completely different line of research. So I'm a computer engineer, and I'll talk about sustainable computing and how to use computing for sustainability. Now, computing is a major energy consumer. There are many anecdotes you'll find if you Google it. Several percent of US electricity is devoted to computers, just the large-scale computer centers, like data centers serving the cloud, supercomputers, and the like. Here's another anecdote. A supercomputer can alone cost hundreds of thousands of dollars per day of electricity costs. So these are huge numbers, and it grows because many of the things we do today, from finance to healthcare to data analysis to scientific computing and all, relies on large-scale computing centers. And this doesn't even include all the other computers that are not as part of large data centers. Now, I saw a quote yesterday: computing is like potato chips. There's never enough. So we'll always compute more. We are greedy. We want to compute more, solve more complex problems. So what can we do to make computing sustainable? One line of research we have in my lab is about how to design future, more efficient computers. So if you look at computers today, like these are computer chips on the left side from the last couple of years, they are already really efficient just compared to a couple of years ago. We have many core systems, heterogeneous systems with CPUs and GPUs together with accelerators. Now you can put in an interposer, a whole bunch of different FPGAs and CPUs, connect them. So the efficiency compared to just a couple of years ago is off the roof. But like I said, there's always more computing demand. So now we are looking into how to design computer systems with emerging technologies. My lab looks into 3D stacking, how to make these like little apartment buildings of chips and connect them, including with the appropriate cooling system, how to use optical interconnects on chip, how to use optically addressed memory to reduce the efficiency gap of accessing memory. So we don't do the devices, but we do the system design and architecture to be able to use these devices so that we can actually have these technologies in the market in a much sooner time than what we can achieve otherwise, right? So we do design automation, we do architectural design, we look into application, how to tune everything across the computing stack so that we can actually adopt these technologies. So that's one thing my lab is working on. Another line of research is how to remove efficiencies more efficient, how to remove inefficiencies more efficiently. So computers are efficient, but they also do a lot of things that are not efficient, right? So you are running a climate change simulation of some sort or drug discovery. You are running on a supercomputer that you ran something, your research, it took you a day. 3 days later, you did the same thing pretty much. Now it took you 5 days instead of a day. What happened? Same computer, pretty much the same software with little tweaks here and there. Nobody knows. Like there's a lot of complications that can go on. And these are expensive systems. We just wasted 4 times the energy that we could have, right? So my lab designed techniques to learn from known problems using machine learning. That's the top line. Basically, we design models to learn from known problems. And then that way, next time we see them, at least we can diagnose them, and then we can move towards a solution to make computing more efficient. We have a whole software suite to do this, in addition to having synthetic anomalies that you can model on your computers. And finally, can you do more? Like, can you get a data center and do more with it rather than solely focusing on making it more efficient, right? So what a data center can do in the grid is to actually help balance the supply and demand match problem. Until we have these gigantic batteries that are cheap and green, this is a big problem. So data center can actually do what it's told in terms of increase and decrease the power consumption up and down, like you see in that figure, to actually act like a battery almost. Data centers have huge consumption, but they are plenty flexible in terms of the hardware and software. So we design techniques to make this happen in terms of the optimization, in terms of the software techniques, in terms of all the necessary infrastructure so that data center can act like a grid stabilizer. Okay, and that's it. Thank you.